Next thing we're going to look at is scalars and vectors. Now a scalar has just size or magnitude, but a vector has size and direction, or magnitude and direction. So speed is an example of a scalar, whereas velocity is a vector. So velocity is speed with direction. And then we're going to look at the other vector equivalents of these scalars. So you can see here, distance is a scalar. The vector equivalent is displacement. Speed is a scalar. Its vector equivalent is velocity. Acceleration could mean change in speed. Acceleration could also mean change in velocity. So we'll see the difference in those. And then other scalars you've got are mass, length, and time. They've just size. Force, well, I quite often forget, force is also a vector. So just be careful on that one. Okay, going to look at a couple examples here. And this is going to bring in the ij components as well. So it says Rory has a displacement vector of 13I minus 7.5j relative to his house. Find his distance. Okay, what on earth does this mean? So first of all, 13I means I go 13 to the right, minus 7.5j. J is the 1 unit vertically up. So minus j's are going to be down, so it's 7.5 downwards. That's really what it is. So that's how he's moved. He's moved 13 to the right and then he's 7.5 down. His distance then is what we're looking for. Okay, so that's really the distance we're looking for here. So you could just use Pythagoras and say the distance is equal to 13 squared plus 7.5 squared and square root all of that and see. And let me just check that and see what I got. So 13 squared plus 7.5 squared square rooted. And then that works out to be 3 sig figs. It's 15.0 kilometers to 3 sig figs. Okay, right, on this, if you had A was a vector xi plus we'll go for yj. For yj, then your modulus of a, that means your size of a is just equal to x squared plus y squared and the square root. Okay, so for in this example, we could have just said here our distance or vector, say we'd said our a was equal to 13i minus 7.5j. Then your modulus, or your distance in this case, would be 13 squared plus, use brackets, minus 7.5 squared and square root. And again, you would get 15.0 kilometers to 3 sig figs. But very important that we understand this. You've probably seen this already on your AS1, or maybe even your GCSE further maths if you've done it. But that's really where this is coming from. So you don't really want to have to do that diagram out every time. You could just jump to it and do it this way. Okay. Right, next example, last example for this wee video, says a ball is kicked with a velocity of 10I plus 8j. Find the speed and direction of the ball. Okay, right, we will do a diagram because it asks you to do the direction anyway. So you've gone 10I, so it means 10 to the right, and then 8j, so 10 vertically, and we want to find this speed. So the speed is going to be the length of the diagonal just, so what it's actually gone. So the speed in this case, I'm just going to say it's going to be 10 squared plus 8 squared and the square root. And when you did that, you're going to get 10 squared plus 8 squared, square root of 10 squared plus 8 squared and square root of that. That gives you 2 root 41. That's an exact perfect answer. I'd always put that in, and then I get that as a decimal. So to 3 sig figs, 12.8 meters per second to 3 sig figs. Okay, right. They also wanted me to do the direction of the ball. So there we had our theta. So the direction of the ball then, we're going to just say tan of theta, because this is your opposite and this is your adjacent. So tan is equal to your opposite over adjacent. Remember, I'll just put that in. That means tan of theta is equal to 8 over 10. So in this case, theta is equal to tan to the minus 1 of 8 over 10. So shift and tan of 8 divided by 10. And then we get, and I got 38.7 degrees. And that's 3 sig figs. And that is us. And we'll just say that's above the horizontal. Done.